I welcome to all to the course of Computer Aided Engineering Graphics. Myself, I am Satish, working as an assistant professor in the Department of Civil Engineering in Anurag Engineering College. So, in this session, I would like to explain one of the topic in Unit 4, that is development of surface. Now, in this session, what is meant by development of surface, and what are the types of surfaces are available, and what are the methods are available for development of surface, and how to draw the those diagrams on a drawing sheet. So let us will discuss first what is meant by development of surface. See, development of surface is nothing but it is a shape of plane sheet. It is a shape of plane sheet that will be folded, that is folded, and it is converted into a desired object. So then it is called as a development of surface. So for example, it is a some desired object, it is a some shape of desired object. So that object is obtained by how it is obtained. So that is obtained by when you taking a plane of sheet, and then after it is folded, then the desired object is formed. So that is called development of surface. So a development is the unfold and unrolled flat or a plane figure of a 3D object. So this is the before desired object. So then that is called as a plane figure. By plane figure, the desired object is formed. It is also some patterns, and the plane may show the true size of the or area of the object. So we have various types of surfaces are available. So for example, plane surface. So plane surface is nothing but when the object, the development of object by using a plane surface. So plane by using plane objects. See what is mean how what is the example for plane objects. So example for plane object is pyramid and prism. If you take a prism and pyramid, both are having a two bases. So two bases means that is formed by a plane figure or a plane surface. So that is called one type of classification of surface is plane surface, and second classification of surface is surface single curved surface. See, single curved surface is nothing but one of the object is formed by it is a single curved plane sheet. See, the example for single curved plane sheet is cone and cylinder. So, cone and cylinder is the example for the single curved development of surface. So, then third one classification of surface is double curved surface. So which means the object is formed by double curved surfaces. So the example for the double curved surfaces are ellipsoid. Ellipsoid is the example for a double curved surfaces. So ellipsoid, how the desired object is formed by means of double curved shape. So double curved surface is required. So those nothing but the classification of surfaces. Classification of surfaces are mainly classified into three categories. One is plane surface. So the example is pyramid and prism. Second one is single curved surface. The example is cone and cylinder. And third one is double curved surface. The example is ellipsoid. See, after completion of a classification of surfaces, then how what are the methods are available for development of surfaces. See, how to develop the surface of one object. Say for example, square is the one of the objects. See how it is developed means, so the entire surface you will be taken, which means the perimeter of the entire surface you will be taken. So that is the surface development of object. So the methods are available. So we have your five methods are available. One is a parallel line development or parallel line method, second radial line method, and third one is triangulation method, and fourth one is approximate development or method. So parallel line method is nothing but it is a parallel lines. The diagram, the development of surface are the unfolded sheet. So it is developed by a parallel surface or parallel lines. So the example for the parallel line development, so this method is adapted for the shape of prism and cylinders. So prism and cylinder are having a two bases. So two bases means it having a parallel, it having a parallel lines. So that's why parallel line development method are adopted in prism and cylinder cases. And radial line method, in this radial line method, the lines are radially, which means some inclination, the lines are some inclination, whereas a parallel line method, the lines are a same straight line which is perpendicular, which means 90 degrees. But in radial line method, some inclination is there, radial line method. So radial line method, this method is suitable for in case of cone and in case of cone and pyramid. In cone and pyramid case, this method is adopted. Then after triangulation development, in this method is based upon triangulations. The triangulations are formed. So this method is applicable for in case of a sphere and in case of oblique objects. Then fourth one, approximate development method. This method which is approximate based drawings. So which is mostly this method is used in double curved surface objects. So in our fourth unit, we are not discussed a triangulation development and approximate development method, because that is not in our syllabus. That is we are not used. So we are using parallel line method and radial line method, because in our syllabus we have a one is prism and second one is cylinder. So that is a parallel line development, and third one is code, and fourth one is pyramid, that is radial line method. Then the next, parallel line method, we already discussed it. It is used to parallel lines to construct the expanded of each three-dimensional shape. So example, prism and cylinder. So we already discussed these are the parallel lines. And if you take a cylinder like this, the folding and unfolding case, and prism also the parallel line is developed. Radial line method, so this is the radial lines, some inclination. Example for cone, uses lines are radiating from center point. So center point to the lines are radially expanded patterns of three-dimensional shape. Example for cone and pyramid. Then come to the another one, triangulation development. This is the triangulation development case, and the made of a polyhedrons are single curved surface. This is applicable for single curved surface. So example for tetrahedron and other polyhedrons. So approximate development method, it is also the approximate shape of like this, that is a sphere cases. It is used for double curved surface. Then move on to these are the example for developments. We already discussed it. Prism and cylinder are the parallel line methods, and pyramid and cone are radials. These are the radial lines. So these are the representation of radial line from the center or origin point. From origin point, the radial lines are extended. Here also pyramid origin point, the radial lines are extended. These are the radial line method. First two are the parallel line method, and sphere is the triangulation method, and tetrahedron is the fourth one, approximate method. These are the example for developments. And true developments, so is one which no stretching. So the development which is no stretching, that is considered as a true development, and every surface of the development is the same size and same shape of the corresponding surface on the 3D objects. So whenever when the 3D objects is available, the same size or same shape, if you no stitching, no extension, then it is called as a true development surfaces. Example for single curved surfaces, these are the true development cases. And coming to the next one, approximate development, we are not used with stretching. So those are not stretching, but these approximate development are one which stretching or distortion of the process of creating development. So these are the stretching process, and these are the non-stretching. So in true development there is no stretching, and in approximate development there is a some stretching is there. So parallel line development, we already discussed it. Example, prism and cylinders. And for common solids, it is parallel lateral edges and cylinders. We already discussed it, this parallel line and radial line. So method also we discussed it. These are the made from cone and pyramids. In this development, all the elements in the figure. So radial lines that have vertex as their origin. So this is the origin point, and vertex is the top point. So the position of cone, one element lies on the development of plane. So whether it is any type of plane, the base of the cone is a circle. This the base of the cone is a circle with a circumferential equals to the length of curved surfaces. And the triangulation method we are not used it, and approximate method also we are not used. Now the first concept is parallel line development. See how to draw a parallel line development in a drawing sheet. So for example, if you take a first one square shape, so for example, development of the object, if the parallel lines are parallel lateral edges begin by constructing a stretch out line or parallel to the right section. So for example, how to draw a square shape. See how to draw a square shape on your drawing sheet. So if it is a square shape is given, so before going to draw a drawing on a sheet, let us know some points. So first, where the front view and where the top view. If the observer is seen a particular square shape, so the front view is developed. This surface is developed on a vertical plane, and if the observer is seen from the top, so the object lies on the horizontal plane. So the top view on horizontal plane and front view on vertical plane. So these the first basic identification. So where we are drawn base, or where we are drawn a projection of lines. So the projection of lines on the reference line or above the reference line or below the reference line, this is the stage one identification. Then stage step by step procedure. So from to start the development, draw the stretch out of line in front view. So front view and top view, so to the base of the prism and equal to the length of perimeter of the prism. So perimeter of the surface or prism, how much the perimeter is there, so that is length to perimeter of the prism. First draw the another line front view along the top of the prism. It is equal to the length of the stretching out. So first you need to draw a front view and top view. Front view on vertical plane and a top view on horizontal plane. If you take a reference line at the middle, this is the stretching out or perimeter of the surface. So this is the initial position, and this is the extended second stage position, step 2. So in step 2, if you know the step 2, see how to draw a step 2. Locate the fold line on the pattern by transferring the distance along the stretching out. So we need to draw a length of the square shape. We have a 4 sides. So 4 into 4, if it is the each side meter 4 meter, so 4 into 4 we can 16 160 mm, which means 1.16 centimeters. So draw this line 16 centimeter, the length of a square shape. See now how to draw a step 2 or second stage. First stage, how to draw. So we have a square shape is given, each side for example 30 centimeter is given, for example 3 centimeter is given, 30 mm. So draw each side 3 centimeters. So if it is a front view, draw the front above the reference line. If it is a top view, draw the horizontal plane. So front view are drawn on vertical plane, and top view are drawn horizontal plane. So the rectangular position, if you take a 6 centimeter, draw a 6 centimeter distance height or the axis height. So after that, the length distance. see how to identify or how to estimate the length distance or perimeter of the surface of the prism. So that is four sides into each side at 3 centimeters, so 12 centimeters. So draw a 12 centimeter horizontal line and take a distance 1 to 2 distance 3 centimeter, again 3 centimeter and 3 centimeter, again first position again reappeared, the again last position 1 2 3 4, and top and bottom, if you take a top and bottom also same dimension 1 2 3 4 and same 3 centimeter dimension. So this is the first example prism, how to draw a prism of development surface of a prism.